Hello everyone, I'm going to be going through a time of flight question from 2023 AS paper 1. Yeah, the whole question's 10 marks, but we're going to start off with a calculation which is 5 marks. Yeah, so telling us that compound X is dissolved in a polar volatile solvent and is ionized by electrospray ionization. So remember guys, with electrospray, this is when you're gaining a proton to create your positive charge, and they're telling us that each ion is accelerated so that it has kinetic energy of this, and the kinetic energy of an ion is given by this equation, and they're giving us what the units are all measured in, and the time of flight along the 0.75 meter flight tube is 2.48 times 10 to the minus 5. They want us to determine the mass in grams of 1 mole of X, and they've given us Avogadro's constant. So first of all, yeah, we're going to be working out the mass, right? So let's maybe rearrange the equation first. So we got KE is equal to half mv squared. Therefore, if we times both sides by 2 and divide by v squared, we'll get that m is equal to 2ke all over v squared. Now, v, we've been told, is meters per second, so that's obviously distance over time. I think most of you know that anyway. But yeah, and we've been given the distance as 0.750 meters, which is the units we want, and same with the time in seconds, which is 2.48 times 10 to the minus 5. So therefore, our mass is going to be equal to 2 lots of 1.36 times 10 to the minus 16 all over 0.750 all over 2.48 times 10 to the minus 5, and that's all squared, right? So m is equal to 2.97 times 10 to the minus 25. And remember, earlier we've been told that the mass is in kg, right? But we want this in grams actually, so we could times that by 1,000 to get it in grams, but also we want to times it by Avogadro's constant to find our mass of 1 mole, because we currently just have the mass of 1 ion, right? So let's find the mass of 1 mole in grams, obviously. That's going to equal to 2.97 times 10 to the minus 25 times by 1,000 and then times by 6.022 times 10 to the 23, which is equal to 179 to 3 significant figures, right? But we would usually be done here, right? But remember, this is the mass of 1 mole of X ions, right? So remember, when we did electrospray, we did X plus H plus, which got us XH plus. And this right here is what's being, put through this mass spectrometer, right? That's the ion that's being accelerated. But we want the mass of just compound X. So what we have to do is subtract 1 for the mass of the proton. So the mass of X is going to equal 279 subtract 1, right? Which times 78. So yeah, a bit of an interesting last part there, but yeah, just if you understand what the question is asking you, then you should be okay. So that's a nice little 5 marks. Now let's move on to the next part of the question. So they're telling us that a mixture of gases is analyzed using time of flight mass spectrometry. The mixture contains argon, carbon dioxide, nitrogen, and oxygen, and the mixture is ionized by electron impact. So not electrospray this time. They're just asking us to state the meaning of the term electron impact ionization. So just remember, with electron impact, you're just firing a bunch of electrons and knocking electrons off molecules or atoms to give them a 1 plus charge, So you can just say high energy electrons from an electron gun are used to knock an electron from each molecule or atom. Okay, so just a nice definition there. You could like make a flashcard or something, whatever, but could definitely come up. Now they want us to identify the ion formed from this mixture that reaches the detector last and justify answer. So remember, in the spectrometer, all the ions have the same kinetic energy. So the one that gets a detector first is going to be the one with the lowest mass, the one that gets the last one with the largest mass, right? So let's just work out like the atomic or like molecular mass of each individual element or molecule in the mixture. So argon is 39.9. CO2 is, so we got 12 from carbon and then 32 from oxygen, so 44. Nitrogen is such a bad drawing. Nitrogen is 14 times 2, so 28, and then oxygen is 16 times 2, which is 32. So it's going to be carbon dioxide, as that's got the highest molecular mass. Remember, they're asking for the ion, so we need to put a positive charge as well, which obviously doesn't really look right. But yeah, and justification has highest mass. Okay, nice, easy 2 marks there. And on to the last part of the question. State how ions are detected and how the abundance of each ion is measured in a time-of-flight mass spectrometer. So kind of just a recall question. I've seen this a couple times, so kind of just remember this. But I mean, obviously it makes sense. So ions are detected. So remember, they're accelerated in your spectrometer, same kinetic energy, and eventually they hit your negative plate and gain an electron. And then when you gain that electron back, you generate a current. Okay, so hit negative plate, and then obviously you're going to gain, each ion gains an electron, which generates a current. Okay, and then with the other part, how abundance is measured. So this is another really just fact recall. It's just that the abundance is proportional to the size of the current. Okay. All right. Well, that is the end of the question. Hope you guys enjoyed, and